Continuation with our lesson on the gas saws. Right now we've covered the combined gas saw, which is the one that you see up here. It's pressure, volume, and temperature. There is a variation of it. There are multiple ones. You got Boyle's law, Charles' law, Gay-Lussac's law. They're all the same. They're all components of one law, which is the combined gas saw. So you might notice some of them will omit pressure, volume, or temperature. It's not included. That is after it follows the word constant. So you're probably gonna see next to your formulas, pressure is constant. If pressure is constant, you're going to eliminate pressure. If volume is constant, you're going to eliminate volume. If temperature is constant, you're gonna eliminate temperature. Why is that? It's basically telling you that pressure 1 and pressure 2 are the same, and therefore they cancel each other out on either side of the equal sign. The same thing with volume. If volume is constant, then volume 1 and volume 2 are the same on both sides of the equal sign, and therefore they're gonna cancel each other out. And if temperature is constant, the same thing. So a key word to look for in your problems is constant. Constant probably means it doesn't change, and constant, when it doesn't change, and gas saw means that they're equal to each other. So you're gonna wanna just cancel that part of your formula. Remember to keep in mind the units that are used for either pressure, volume, and temperature, especially pressure. Make sure you pay attention to that so that the letters and the abbreviations don't seem weird to you. You make sure that you familiarize yourself with those. So let's actually look at my second example that we're working on. This is number 5, again in the packet that has your formula sheet in front of it. By the way, you always want to have that out as a reference. So this is number 5. Now let's go ahead and look at it. I've written my formula based on the information given. If you look at number 5, it says the sample of gas has a volume of 215 centimeters cubed. It says at 23.5 degrees Celsius and 84.6 kilopascals. So it actually mentions volume, temperature, and pressure. Volume, temperature, and pressure. So more than likely, I'm going to use my entire formula. I'm not going to cross out pressure, volume, or temperature. It doesn't say anything about constant. So because nothing is constant, they're all different on both sides of my equal sign, I'm going to use all 3 components. What volume will the gas occupy at STP? Now, there's a new term called STP. That stands for standard temperature and pressure. Standard temperature and pressure. Standard means normal, the norm. At a given atmosphere, in a specific amount of pressure, in a specific amount of temperature, in a specific amount of volume, there's an STP. It's a standard. It's a given to you. Where do you locate it? It's in the front of your, again, packet where it has your formula sheet. You're gonna notice a square that says standard conditions. Standard conditions. It's towards the bottom right, standard conditions. You might want to highlight that entire square. You might want to be familiar with it because you're going to use it every time it says standard temperature and pressure, STP. Now, my standard temperature, as you can see there, is always 273 kelvins. It's always 273 kelvins. That's my standard temperature, no matter what. It's just a given in a normal situation when it comes to science. Then, my standard pressure is based on my unit. So I have to look at my problem. If you're looking at number 5, you're gonna notice that number 5 is using kPAs. Once again, kPAs is a unit of pressure, kilopascals, which means I'm gonna use my standard pressure for kilopascals. So you're gonna locate that. You're gonna see first is atmospheres, then millimeters of mercury, then centimeters of mercury. Don't worry about that. That's in case you need to convert. The next number, the 101.325, is for kilopascals. Once you notice that the 101.325 is for kilopascals, the 101.325 is for PA or pascals. Those are 2 different kilopascals. Obviously, you have a larger unit than just pascals. So once again, remember the conversions of a kilo means 1,000. So once again, the 101.325 is for kPAs. I want you to make a note of that because you are going to use that number several times. So that's what standard temperature and pressure is, STP. With that being said, let's continue working on my problem. So again, look at number 5. We've already read it. It gives me a volume, it gives me a temperature, it gives me a pressure, and also gives me STP. Now it says, what volume will the gas occupy? So after writing my formula out, I want to remember, what is it that I'm solving for? What am I going to be missing in my entire formula? In this instance, it says, what volume will it occupy? So I'm actually missing volume 2. I'm going to be missing V2 in my formula. Everything else is given. Although you don't have 5 numbers there of 5 different variables that are given, you do have all 5 of them. So anyway, I've written out my formula, P1 V1 T2 equals P2 V2 T1. That's my formula. Always rewrite it. Remember, that's the first step to your problem. Second step is to derive. What is it that I'm solving for? I already know I'm solving for volume 2. My third step is always, do I need to convert? Do I need to convert? In this instance, you do. You need to convert twice. Notice how there's 215 cubic centimeters cubed. I cannot use that unit. Remember, volume is liters. Now, the great part about this is that conversion is pretty easy. You just actually move your decimal to the left 3 times. So 215 cubic centimeters is equivalent to 0.215 liters. Now I've kept 3 numbers just because they provided me with 3 numbers. Gives you a more accurate answer. So I've just converted 215 cubic centimeters to 0.215 liters. I just moved my decimal to the left 3 times. That's my conversion for volume. That's done. Then I notice that my temperature 1, the first one given, is in degrees Celsius. Again, I cannot have that because temperature is in Kelvin, must be in Kelvin. So I'm simply gonna add 273 to it. So you notice up here, 23.5 degrees Celsius, add 273 to it is going to give me 296.5 kelvins, 296.5 kelvins. I've converted my volume to the correct unit. I've converted my temperature to the correct unit. I know I'm doing this correctly so far. That's my third step. Write your formula, derive or figure out what is it that I'm solving for. Do I need to convert? Next, you're just plugging in your numbers into your formula. So you're gonna copy the same formula down here. Instead of letters, you're gonna replace them with numbers. So pressure 1, the first pressure mentioned, as you can see right there, is 84.6. How do I know it's pressure? Because it says 84.6 kilopascals. Kilopascals is only for pressure. Pressure 1 is 84.6. I'm looking for volume 1. I've already converted it. It says 215 cubic centimeters. I've converted that to 0.215 liters. I put 0.215 right here. Then I'm looking for temperature 2. Don't forget, my temperatures are switched. Temperature 2 comes first. So what's my temperature 2? It doesn't give me a second temperature. It just says STP. Every time you see STP, remember, you're gonna flip over and you're gonna look at standard conditions. My standard condition is always for temperature 273. So I'm gonna place that there for T2. So I got my pressure 1, my volume 1, my temperature 2. Equal sign, then I'm looking for my second pressure. My second pressure is also not provided. Remember, it just says STP. That's a standard pressure. Again, you look for standard pressure of kilopascals because that's the unit being used for pressure. You recognize that it is 101.325, 101.325. This is just standard pressure. You just write the number down. It's a given to you. It's a constant that you're always going to use for pressure when it comes to standard conditions. Want to make sure you just write it down exactly how it is. So I have my pressure 2 is 101.325. My volume 2, that's what I'm solving for. It says, what volume will it occupy? So I just placed volume 2 right there. Hopefully you can see that. Zoom in a little bit if you need to. Volume 2 is the variable I am solving for. Then I'm missing my temperature 1, T1. Remember, they're switched once again. Temperature 1 comes second. My first temperature mentioned is 23.5 degrees Celsius. I've already converted that to 296.5 Kelvin. I placed it over there, 296.5 Kelvin. So I have all 6 of my components of my combined gas saw. Pressure, volume, temperature, pressure, volume, temperature. I'm solving for V2. Once again, it turns into a simple math problem. I'm gonna multiply all of these on my left side. So I multiplied 84.6 by 0.215 by 273, and that's gonna give me 4,965.60. Right there. Then on this side, I'm gonna do the same thing. Remember that I have my V2 still being solved for. So I'm gonna multiply 101.325 by 296.5. Again, that's going to give me 30,042.86. This times this is going to give me that number. I already went ahead and did all my problem. This is why it looks like that. But this is right here, and then V2 is still to solve for. So I've multiplied that side, still solving for V2. In order to solve it, I need to isolate it, and therefore I need to divide this side by itself in order to leave this by itself. So I've divided this by this. What you do to one side, you have to do to the other side. So I'm going to divide 4,965.60 by my 30,042.86 in order to leave V2 by itself. Divide this by this. The answer is going to give me 0.16 liters. 0.16 liters. Now you'll notice if you, for whatever reason, forgot to convert my volume, at the end, you can once again move your decimal 3 times. So those of you that forgot, for whatever reason, to convert your volume, you're gonna end up with like 165.28. You'll notice that if you move your decimal 3 times, it's gonna give you 0.16. So once again, I need you to realize that the conversions are important. You cannot wait to the end to convert to temperature. It might not give you the correct temperature. It might not give you the correct answer. Don't risk it. Just automatically get in the habit of following the same steps over and over. Just as a recap, always write your formula first. Secondly, always make sure to know what is it that I'm solving for. Third, I want to know, do I need to convert something? Lastly, I'm going to plug in my formula with the correct replacement. So every letter gets a replacement except for the one that I am solving for. Again, this is for any worksheet that at the top says Boyle's Law, Charles' Law, Combined Gas Law. You are supposed to do these based on both of these lessons. You already have enough information in order to do so. There is a video that went before this one, and then there's another set of videos that I already taught for chemistry class for the 11th graders. You can watch those. So there's at least 4 videos on the combined gas law. You can watch again, just in case you need to remind yourself what is going on. So the formula is important, your units are important. If you follow the steps every time, it's always gonna make sense and you're always gonna get the right answer. The thing that I feel most students struggle the most when it comes to this is you forget how to round. Remember to round correctly. Now this one would have given me 0.165, so technically it's 0.17. We left it there because I wanted to show you how it converted from 165 over 3 times, but I need to make sure that you round correctly. We're not gonna be too particular about it. If you're off by 1 decimal place, you're still understanding the concept. But when you don't round correctly in multiple steps, at the end, it's probably gonna give you an answer that's pretty off. So this is why I want to make sure that you're learning or remembering how to round correctly. Next, another thing that you typically struggle with is your units. You get so confused with what's this, what's that, what's this, what's that. I don't know how to do this problem. You automatically give up because if you remember to recognize your units, it becomes a lot easier. And then lastly, in relation to your units, is you forget to put the right unit with your answer. This has still happened. Chemistry students that took this lesson twice already, this is the second time they learn about gas laws, we have some of them still placing the wrong units at the end. And that's a mistake anyone can make, but it's a mistake you don't want to make because it will affect your grades. Please make sure you use the right units at the end. You already have them here. Volume and temperature are easy. The pressure ones, just look at what is the problem talking about. Now, I want to remind you as well, if the problem doesn't specifically give you a unit for pressure, you're always going to assume it's atmospheres because that's your most common one. That's rare. It might not happen. Some worksheets it doesn't mention. Just use atmospheres and you'll be okay. So this is once again for those that deal with pressure, volume, and temperature only. You might see number of moles or you might see grams in it. That's your ideal gas law, PV equals nRT. We're gonna learn about that later on. If you see rates or effusion and diffusion, that's Graham's law. I've already made videos for that for the previous class. I'll remake some other ones to explain it better to you. But right now I need you to work on the worksheets that are specifically for this. Again, these are due next Thursday, so you might wanna get started on them.